JavaScript is a popular general-purpose programming language you can use to power web servers, create desktop and mobile applications, even control robots. But JavaScript was initially designed to run in the browser, to make web pages responsive to mouse clicks and other visitor input. It's one of the essential tools for creating fun, interactive, and useful websites and applications. I'm Gil, a developer and instructor here at Treehouse. In this course, you'll start to learn how to bring web pages to life using the power of JavaScript. Now, this course assumes you know your way around JavaScript basics, so make sure you've completed the prerequisites listed in the teacher's notes with this video before continuing. JavaScript lets you create interactive web pages that respond to a user's actions. For example, a user clicks on a button or fills out a form, and then something happens as a result. New content appears on the page, form fields provide validation hints, a video plays, and more. First, let's look at examples of JavaScript's role in helping you create immersive, interactive web experiences.
Here's a website displaying documentation and resources for a popular JavaScript library called React. These docs, like many library and tool documentation sites, are usually made up of static web pages. For the most part, there's no JavaScript interactivity. The site contains only text and links, which is perfect for this site because it's all about delivering paragraphs of textual information. It's just meant to model a regular page, like a page in a book that you can read. Next, let's check out this JavaScript calculator. Clicking a number button makes that number flash and appear in this display. I can clear the display, then, for example, add 8 and 9. Click equals, and the number 17 appears. This is what I mean by interactivity. When the page loads, JavaScript code tells the browser to listen for button clicks and perform math in response to those clicks. Then it alters the display to show that math as it's performed. Now let's have a look at a fun interactive website that highlights the fall harvest of Cordo olive oil. After the page loads, we can use the slider at the bottom to explore the site. This triggers an animated transition into a video about the product. Now we're presented with a menu. Clicking a menu item triggers all sorts of changes to the page. We can also click on the navigation buttons along the right side of the page, and the page transitions to the corresponding information. So now you're starting to understand how JavaScript can make websites more engaging and pleasurable to use. Let's look at one more example. Google Sheets. This is an example of a full-blown web application. You can type information into cells. You can right-click on cells to bring up various options to, for example, insert or delete rows, columns, and cells. And you can navigate menus for other functionality, such as sorting, filtering, or even adding new sheets. All of this interactivity is accomplished with JavaScript, which is listening for actions like clicks and then changing what we see based on those actions.
To make static pages interactive with JavaScript, you'll start by breaking interactivity into distinct actions, selecting elements on the page, manipulating or doing something with the elements, and listening for user actions or events, like a mouse click. You'll learn how to take control of your web pages by accessing something called the Document Object Model, or DOM, with JavaScript. The DOM is where all these actions take place. There's so much to learn, and we're going to have fun in this course, so let's get started. JavaScript runs and can be found in many places or environments these days, but the most common environment is the browser. Every browser has a built-in JavaScript engine that reads, understands, and runs the instructions in a JavaScript program. The browser environment provides ways to access and change different parts of the web page with JavaScript. Understanding how that works requires an understanding of the DOM, or Document Object Model. You've learned that almost everything in JavaScript is an object or can be treated as an object. JavaScript objects can have properties, which define their characteristics. Properties of objects can also be accessed or set in the programs we write. Objects also have methods, or properties of an object that are functions. Methods allow actions to be performed on the object. For example, when the log method is called on the console object, you can log a message to the browser's console. The DOM is an object-based representation of a web page with its own built-in properties and methods, which can be read and modified with JavaScript. This is what allows developers to program a web page using JavaScript. The DOM represents a web page, or HTML document, as a tree-like structure. In a typical HTML document, there's an HTML, head, and body element. Nested inside those are other elements. For example, the head contains a title element, the body might contain heading, paragraph, and UL elements, to name a few, and a UL element would have LI elements inside. These elements can all be thought of as being in a tree called the document tree. Just about every element or item within this document tree is referred to as a node. Now, don't worry too much about the word node for now. Just know that a node is like a regular JavaScript object and that there can be different types of nodes in this tree. For example, HTML tags are element nodes, and any text or content inside elements are called text nodes. Notice how the DOM tree resembles a family tree. In fact, developers describe the relationship between DOM nodes in family-like terms. The HTML element is the root node of the tree and is the parent of the head and body nodes. The body is the parent of the H1, P, and UL nodes. The LI nodes are all children of the UL node, and the LI nodes are siblings of each other, just like the head and body are siblings. Text nodes, the text or content inside elements, are the most deeply nested nodes in the tree, and they do not contain other nodes. The browser converts the structure and content of an HTML document into this tree-like object model that allows JavaScript to read and manipulate the page's content, structure, and styles. As you'll soon learn, JavaScript uses these family relationships and this tree-like model for understanding and altering the structure of web pages. So what does the DOM actually look like? If the DOM is made up of HTML elements, is the DOM the source HTML of your web page? Well, not quite. So let's dive a little deeper into this concept.
I am on a web page now, which just happens to be a helpful JavaScript reference on MDN web docs. Right or control clicking on the page lets me view the page's source HTML. Even though the DOM gets created from your source HTML, what's shown here is not exactly the DOM. This is the static HTML that's usually sent by the server and loaded by the browser. However, this is what's parsed by the browser and turned into the DOM. When the browser loads a document, like the source code, all the HTML tags are converted into objects and put into that tree-like structure I showed you earlier. And the DOM itself is a whole lot smarter and more dynamic than this static source code. It's a living model of nodes in that tree-like structure. The DOM can automatically fix errors in the source code. For example, if you omit essential tags required in the document, like the head and body of a page, the DOM will correct that for you automatically. The DOM also allows you to dynamically change and add content and new elements to the document with JavaScript. A visual and more accurate representation of the DOM is what you see when you inspect your page using the browser's developer tools. In Chrome, for example, you'll find the developer tools in the top right menu by going to More Tools, then clicking Developer Tools. In the Elements panel, any existing elements and any nodes you change or add to the page with JavaScript will show up here, as well as any of the document corrections I just talked about to make your HTML valid, like add missing head and body tags. So here, for example, is the root HTML element and its child head and body elements, which are siblings within the root element or node. Before you can make a web page interactive with JavaScript, you'll need a way to access elements or nodes in the DOM. Next, you'll learn about the window and document objects. These special objects provide the entry point into the web page's content.
Earlier, you learned that JavaScript can run in different environments. The environment in which JavaScript runs is called the host or global environment. The browser as a global environment provides variables, objects, and functions additional to those in the core JavaScript language to make things happen inside the browser window. It's what allows your JavaScript code to connect to the DOM and manipulate a web page. We can explore this browser environment through the web browser's developer tools. Now, Microsoft Edge, Firefox, and Safari have similar features, but I'll be using Chrome in this course. To follow along with me, launch the workspace with this video, or download the project files and use your preferred text editor.
In your workspace or project files, the file index.html contains the markup for a simple daily task list application. I've provided all the styles for this app, which you can view by previewing index.html in the web browser. This application doesn't do much yet. It's static, but that's all about to change soon. You're going to write JavaScript to build up this app and make it interactive. You'll be able to add new tasks, remove specific tasks, even show and hide the task list. Let's first use the browser's developer tools to investigate and interact with this page using JavaScript. In the console panel, we can type JavaScript code in real time, and it will run as if we'd written it into the current web page. For example, you're probably familiar with the alert method. Alert is a browser function that shows a message window to the user via an alert dialog. Let's try it out here by passing alert the string, "I made the browser message me." I'll press enter, and my message appears. We can also see the current URL by typing location.href. And we see that the URL in the console matches the URL in the address bar. So where did alert and location come from? We didn't create them, and they are not defined in a JavaScript file loaded by the HTML page. Alert and location are part of the browser's global environment I mentioned earlier. The browser has a global object called the window object, containing all the properties and methods available to the current browser window, or what you're viewing in the browser tab. So let's type window into the console and see all the properties and methods it contains. This is the window object, and Chrome's developer tools gives us a handy way to explore objects. Click the arrow to expand the object and view all of its properties and methods. Notice how the window object has many. You can think of these as the controls the browser exposes to JavaScript to let it interact with the current web page. For instance, here you'll find familiar functions like alert and the location property we just used. Expanding this location object shows that it contains the href property holding the current URL. All of these globals are properties on the window object. I'll demonstrate this by first clearing the console by typing Ctrl-L, then typing window.alert, and passing alert the string, "The browser messaged me again." And this pops up the alert dialog box, just like before. And window.location.href also works in the same way as before. Keep in mind that you're able to call any properties and methods of the window object without explicitly referencing window dot, because window is the global object of the environment our JavaScript is running in. So its properties and methods are automatically globally available even without referencing the window object specifically. So accessing any of these properties and methods without typing window first is sort of a shorthand way of doing so. The window object also contains a really important property named document, which is an object, and it's the entry point into the DOM loaded in the current window. We can use the document object to select and control elements of the web page. This document object and some of its common properties are what we'll focus on for the rest of this course. The document object is the root of every node in the DOM. For example, if I access the document property in the console with window.document, the console returns a reference to the current document contained in the window or current browser tab with elements such as HTML, head, body, a div, and so on. You just learned about how window objects and methods are automatically attached to the window object, so typing only document returns the same. Remember, the elements in this current document are now treated as objects via the DOM. Those objects are called nodes, and you can call different methods on them and read or modify their specific properties. I can start doing things with JavaScript, like reading their contents. For example, document.title returns the page's title text. I can change the title text by pressing the up arrow key on my keyboard to bring back the previous command and assigning document.title a string with the new text to display. My web page, notice the new title in the browser tab. To return only the body of the current document, type document.body. This returns an object representing the body tag of the current page and all of its child elements or nodes. And check this out. Once you have a reference to the body, you can change some of its style properties, like the background color, like this, document.body.style.background color equals tomato. You'd typically do most style changes with CSS, but this is an example of how you can access and change parts of the current page with JavaScript via the DOM. So here, we're setting the background color property of style, which is a property of the body object, and that itself is a property of the document object. We know that document is a property of the global window object, so we don't need to reference it here specifically. And this changes the background color of the page's body. Check the teacher's notes with this video to learn more about why the background color property is written this way in camel case instead of how you'd write it in CSS. I'll talk more about this later too. Earlier, I mentioned that the changes you make with JavaScript do not appear in the HTML source code. In the Elements panel, notice how the body tag now has a style property with the background color I just added. If I view the page's source and find the body tag, those changes do not appear here, and the title element is not updated with the text I added with JavaScript. This illustrates the difference between the actual source HTML and the DOM that we interact with using JavaScript. Similarly, you can access certain elements, like the body, and change its entire contents or even remove it from the DOM. For example, you've used the inner HTML property in previous JavaScript lessons to get or set the HTML inside an element. So I'll set document.body.innerHTML to an H1 with the text "Hello World." Press Enter, and this replaces everything inside the body with the new heading. Refreshing the page source still displays all the original HTML code within the body, and refreshing the task list app brings back the original HTML elements defined in the HTML file. I can also remove the entire body from the DOM by calling the remove method on the body with document.body.remove. The body is now removed from the document. I'll refresh the page source. And again, notice how all the original source code remains unchanged. The Elements panel, however, shows the updated DOM without the body element. You'll usually make changes like this based on a user's interaction with the page. Clicking a button, for example, might change the color and background color of the page or remove content from the page. And don't worry about what style.background color and .remove mean for now. We'll go over this code more in depth soon. I've typed all my code into the console so far, but even when you write inline JavaScript inside script tags or load an external JavaScript file, you can immediately begin accessing and controlling HTML elements via the DOM. When you load a web page in your browser and start interacting with it, you're generating all kinds of events or actions that the browser is listening for and registering behind the scenes. We can write JavaScript to make the browser do something in response to a user action. For instance, clicking a photo thumbnail pops up a larger version of the photo. Scrolling to a specific part of the page initiates an animation, or something might happen when clicking into a text field, submitting a form, and so on. A user may spark tens, hundreds, or even thousands of these events, and in most cases, the browser doesn't do anything special in response. To have the browser do something in response to one of these events, we have to write some JavaScript code that first listens for a specific event and then handles and responds to it. In this video, I'll introduce you to what are called event listeners and how to use them to make your sites and apps respond to user actions, specifically clicking on an element. We'll get started by identifying the element to be clicked and then performing some action on the page as a result. In your workspace or project files, open the file app.js. This JavaScript file is already linked to index.html. Let's first access the body of the page, just like we did earlier with document.body. Objects in the DOM, like body, can detect and listen for events that happen when the user interacts with the page. Now that we have a reference to the body element, we can make it listen for mouse clicks using the addEventListener method. After document.body, type .addEventListener followed by a set of parentheses. An event listener is a function that waits for an event to happen. Now the body element is set up to listen for any given events to fire. There are many different kinds of browser events, such as key presses, scrolling, or mouse moves. You'll learn about those in a later course, but let's start with one of the most common user interactions, and the one we'll use a lot of in this course, clicking. Keep in mind that on touchscreen devices, tapping is equivalent to clicking. We're going to pass addEventListener two arguments, the event type to listen for as a string, and a function that performs some action in response to that event. First, we want to listen for any moments that a user clicks inside the body, so the first parameter we'll pass in is the string click, the event's name. The body is listening for clicks. Now we'll tell the browser what to do when a user clicks anywhere inside the body. We'll do that by passing a function as the second argument. Now I'm writing an arrow function, but you could also write this as a function declaration. You can review an example of that in the teacher's notes. Think of this event listener as a method that sends a signal to the browser that something has happened within the body element. In this case, a click. All right, the event handler is now set up. The function will execute as soon as the click event gets registered in the target body element. So let's have the function log a message in the browser's console. Within the function body, add console.log and pass it the string. You clicked the body of the page. Refreshing the browser and opening the console, no message appears yet. Did we add the event handler correctly? Well, let's click anywhere on the page to find out. It logs the message. Good. So we've successfully set the body up to listen for events. If you click on it again and again, the browser continues to respond to each click and log the message. Now let's try changing content inside the body. This time, I'll store a reference to the body element in a constant named body with const body equals document document.body. And now I can reference the body element in my event listener using the variable body. Inside the event listener's function, I'll update the inner HTML of the body with body.innerHTML and set it to an h1 element displaying the text "Hello World." This selects or finds the body element in the document, then replaces all of its inner HTML with just an h1 with the text "Hello World" when you click anywhere inside the body. Now, if I reload the browser, the page resets to its initial state. So let's go through this code line by line. On the first line, we get a reference to the body element and assign it to a variable. Next, we call the add event listener on the body, instructing the browser to do something when it's clicked. And finally, we tell the browser to manipulate the body element by changing its inner HTML for every click event. Don't worry too much about add event listener, events, and this function right now. We'll go over how a lot of this code works more in depth soon. The main thing to note for now is that we selected an element, set it to listen for a click event, and perform a function as a result. This is a typical sequence when controlling a web page with JavaScript. This ability to listen and respond to events allows users to interact with a web page. There are many other ways to target elements on the page with JavaScript, and that will be the focus of the next stage.
In this stage, you learned about the browser as a global environment for JavaScript, and that the browser has a global window object providing all the properties and methods of the current browser window. This window object also contains an important object called the document object, representing the HTML document loaded into the browser window. It serves as the entry point into the web page's content. You also learned that the DOM, or document object model, is an object-based representation of a web page, and it's what allows JavaScript to access and make changes to the page. You can think of the DOM as a tree-like structure of HTML tags that stem out from one root document node. Finally, to control an element with JavaScript, you first access the element, then you can read or update its contents and properties. An element in the DOM can also listen for a browser event and execute a function in response. Usually this event is a user action, like a mouse click. Now that you have a high-level view of JavaScript and the DOM, let's get to the fun part and write more code. See you in the next stage. There's a two-step sequence when controlling an element in the DOM with JavaScript. First, you access the element, then you can either read its contents or manipulate it in some way. In the previous stage, you wrote JavaScript to change the background color of the body element, update the title text, even replace everything inside the body with the text "Hello World." How exactly did the browser know which elements to target? Well, we first had to access the element, using document.body, for example. Selecting parts of a web page is a big topic, and it's what this section of the course is about. Selection is a way to identify an element for a browser, so the browser can find it and make it available to do something using JavaScript. There are several ways to access specific elements in the DOM. For example, document.title and document.body are default and quick ways to access those elements. But your users will often interact with other nested elements, like buttons, images, and forms. For this, the document object provides various selection methods. In this video, we'll begin selecting and changing elements in our page using some of the most commonly used DOM selection methods.
Let's start by selecting an element by its ID with the getElementById method. This method belongs to the document object, which again represents the current web page. It looks through the entire document for an element with the specified ID, then it returns that element if it exists. In app.js, I'll first delete the code we wrote earlier. Now, if you want to keep this code for reference, you can access and review all the code written in this course by downloading the project files. I'll start by typing document.getElementById followed by a set of parentheses. You pass the getElementById method the ID of the element to locate as a string. I'll pass it the ID headline. Since IDs are required to be unique across your entire HTML document, getElementById returns only one specific element. In this case, the H1 element with the ID headline. Once you've selected the element, you can do things to it, as I showed you earlier. For example, I'll apply a red border with .style.border equals the string solid 2 pixels red. I'll refresh the browser, and good, our script is selecting the element successfully. You'll usually assign the element or collection of elements returned by selection methods to a variable. It makes your code more manageable and easier to read and lets you reuse the selected elements throughout your program. So next, I'll assign the returned heading element to a variable named headline with const headline equals document.getElementById headline. I'll just copy it and paste it on the line above. Now the variable headline holds a reference to the H1 element, and I can make changes to it just as before using the variable. All right, now how about applying the red border or any new styles to the heading when a user clicks a button? In index.html, there's a button element inside the header with the ID button main. You learned how to listen for and respond to mouse clicks earlier, so why don't you pause the video now, select this button, and write the JavaScript to update the heading border on click. Okay, here in app.js, I'll first access the button using getElementById and assign it to the variable button update with const button update equals document.getElementById, passing it the string button-main. We want the button to listen for mouse clicks, then update something on the page, like apply a border to the heading when that click happens. So I'll call addEventListener on button update and pass it the string click, followed by the function to run on click. When we click the heading, the border styles get applied, so I'll move the statement that sets the border style inside this function. I'll save my file, switch back to the browser, and refresh. Click the button, and good. The script is selecting both elements successfully and applying the red border style to the heading when the button gets clicked. We'll cover the details of addEventListener, browser events, and the different ways you can provide a function to addEventListener in a follow-up course. For now, the focus is on selecting elements and doing something to them with JavaScript. And feel free to try more on your own. You could, for example, set a different style property of the headline, such as the font size, font family, or color, or add a button that resets the heading styles when clicked. Earlier, you used the getElementById method to access one element with the specified ID. What if you want an element that doesn't have an ID, or you want to select multiple elements on a page? For example, you might want to select all the items inside an unordered list so you can turn them into to-do list items that users can click to mark a task as done. If you know the tag name of the element, you can use document.getElements by tag name. This method is similar to getElementById with one important distinction. Notice the plural word elements, while getElementById has the singular form element. Not only will you get an error if you mix these up, but also each method returns a different data type. Let's head over to the browser console to see how it works. The purpose of getElementById is to access and return one element in the DOM directly. For example, you've seen how document.getElementById headline returns the one H1 element. The getElementsByTagName method doesn't quite work in the same way, and you use it when you need to access and return multiple elements in the DOM. In the console, let's access the li elements in the document with document.getElementsByTagName, passing it the string li. Notice that instead of the element nodes, it returns something called an HTML collection, and it looks like an array holding these 6 li tag names. An HTML collection is an array-like collection of elements listed in the order they appear on the page. Now, an important distinction to make is that array-like collections like this are not constructed like regular arrays, so they don't exactly have all of the same properties and methods as array literals, for example. Collections will have their own properties and methods, some of which are just like those of an array. For instance, the length property returns the number of items in an HTML collection. This returns 6 because there are 6 li elements on the page. And since you can treat this HTML collection just like an array, you can access elements directly using its index and bracket notation. For example, access the first li element the same way we would get an element from an array using 0, because 0 is the first element of an array, and this returns the first li element containing the text "make coffee." Let's try selecting other elements, like buttons. I'll select the button tags with document.getElementsByTagName, passing it the string button. And this returns an HTML collection holding 3 button elements, and I can see that the button with the ID button main is first in the collection at the 0 index. Now I can, for example, do something to this specific button with JavaScript, like change its color with bracket notation, specifying 0 as the index, then .style.color equals yellow. Remember, even if there's only one element in the DOM with the tag name you've specified, you'd still need to access it like this by its index and with bracket notation. Otherwise, your script will throw an error. For example, selecting the only H1 element on the page and attempting to set its color like this throws an exception, letting you know that you cannot set a color property on something that's undefined. What this message is really saying is that you can't set the style.color of a collection because a collection doesn't have a style property. But specifying the index value of the element in the returned collection with bracket notation works as expected. GetElementsByTagName really shines when you have several elements to select and manipulate all at once. Let's go into our JavaScript file now and use getElementsByTagName to select all the list items in the document with document.getElementsByTagName, passing it the string li. First, I'll try changing their background color. So I'll call .style.backgroundColor. And assign it the string sky blue. I'll save my file, refresh the page, and nothing changes. Looking in the console, I once again get that same error message, cannot set property background color of undefined. Well, we know that you can't call style.backgroundColor or any of the properties and methods for HTML elements on the HTML collection itself because the collection doesn't have the same properties and methods as the individual elements. When you have multiple elements in the collection that you would like to modify, you have to use a JavaScript loop to iterate through the collection, then access and do something to each element one by one. This time, I'll make my code more readable by assigning the li collection to a variable I'll name items. Items now holds a reference to the HTML collection. Now, with JavaScript, I can iterate over all the items inside the array-like collection and do something to them. There are different loops and methods you can use to iterate over an HTML collection with JavaScript. I'll use a for loop, which you've worked with in previous courses. Between the parentheses, I'll type let I equals 0, semicolon I, less than items, dot length, semicolon I, plus plus. If you need a refresher on how for loops work with arrays, be sure to review the links to related Treehouse videos posted in the teacher's notes with this video. I've also included information about other ways to iterate over a HTML collection. Inside the loop, the variable I holds the current index value, so I'll use I and bracket notation to reference each item in the HTML collection and set its text color to orchid with .style .color equals the string orchid. I'll save my file. And in the browser, refreshing the page updates the text for each item in the list to orchid. Good. This was only a simple example of accessing collections of elements and doing something with them. And as I mentioned earlier, you'll usually change text color like this with CSS. And later, you'll learn how iterating through and accessing elements in these array-like objects can be useful. Often, when working with HTML, you'll set class attributes on elements and apply styles to them with CSS. The document object provides a way for us to select elements in the DOM with a given class name with document.getElements by class name. In index.html, let's add a class attribute to some of the items in the unordered list and set it to the class name highlight. It could be any item. I'll add it to the second list item, then the fifth, and the sixth item. I'll save this file and next select them with JavaScript. In app.js, declare a new variable named highlights to reflect what we'll assign to it. Then get all elements that have a class of highlight with document.getElements by class name and pass it the string highlight. I'll save my file, refresh the browser, and in the browser console, I'll reference the variable highlights. Notice that the getElements by class name method also returns an array-like HTML collection. It contains each element with the given class, highlight, in the order they appear on the page. You can directly access any of these elements like we did earlier using an index value and bracket notation. Now, if you want to access and do something with the elements all at once, you'll also need to iterate through the HTML collection and change each element one by one. You could do this using a for loop. This time, I'll teach you a different kind of JavaScript loop you can use to iterate through arrays or array-like objects. It's called the for of loop. It looks similar to a for loop, only more compact. Within the parentheses, you provide a variable that represents the current item being processed in the loop. This is similar to the index variable in a for loop. I'll name it highlight. Follow the variable with the keyword of and the name of the array or collection you're looping over. In this case, the HTML collection assigned to the highlights variable. Inside the curly braces, you provide a statement or action to be carried out for each element that gets passed into the loop. Now, what might we do with each highlight item? Well, normally you might hide or expand selected elements, remove them, or perhaps change them to fit some criteria. For now, let's just set a new background color with JavaScript to show that our selection is working. Within the for of loop body, I'll access the current element assigned to highlight, then set its background color style to corn silk with .style .background color equals the string corn silk. This for of loop looks a whole lot more compact than a for loop, doesn't it? And remember, you can use it with regular JavaScript arrays too. Check the teacher's notes to learn more about it. I'll save my file, and switching back to the browser and refreshing the page displays the corn silk background colors for the highlighted items. Good. This means that the selection worked. All right, up next, I'll show you a more powerful and flexible way to select elements in the document. See you there. The last selectors we'll look at are Query Selector and Query Selector All. These are the most flexible of all the DOM selectors. They accept IDs, classes, tag names, and just about any valid CSS selector. They specifically work well with descendant and attribute selectors, for example. The Query Selector method returns the first element that matches the specified selector, and Query Selector All returns a collection of all elements or nodes matching the given selector. I'll teach you how these selection methods work in the browser console first. I'll start by selecting a button element with document.querySelector and pass it the button tag name as a string. Even though there are multiple button elements in the document, the browser only returns the first one it finds. This selection method is flexible, so I can be more specific by passing it the class or ID of the element I want to select. For example, the button with the class button-toggle. Remember, when using Query Selector and Query Selector All, you need to specify the selector as you'd write it in CSS. This means adding a dot character when selecting a class and the hash or pound sign when targeting an ID like headline. Otherwise, the methods will return null or throw an exception or error in the console. Next, I'll select all the li elements in the document using document.querySelectorAll and pass it the li tag name as a string. Let's see what this returns. This time we get something called a node list, and like an HTML collection, it resembles an array holding all the li tag names. And if we pass the Query Selector All method, the class highlight, it selects and returns a node list containing just the list items with the class highlight. A node list and an HTML collection are very similar. They are both array-like collections of DOM nodes in the order they appear on the page. The distinction between the two is not super important to know right now, but in short, a node list is more flexible than an HTML collection. It can contain any type of DOM node. For example, a node list can contain element nodes and text nodes. You can also iterate through a node list in the same way you would an array, using a for loop, for of, and other array iteration methods like map and for each, which you may not have used yet. However, an HTML collection can contain HTML elements only, and you can't loop over it exactly as you would an array. You don't need to worry about what all this means in this course, but I've posted resources in the teacher's notes if you want to learn more. The main difference to remember between an HTML collection and a node list is that HTML collection is a live data structure and node list is a static data structure. An HTML collection automatically updates each time it detects a change in the items retrieved by a method. Node list remains the same, no matter the changes that occur in your HTML. In other words, every time a new element gets appended to the DOM with JavaScript, for example, an HTML collection will recognize the new element, while a node list will not. Okay, so we know that Query Selector returns the first matching element only, and that Query Selector All returns a node list holding all elements matching the selector. Let's now jump over to app.js and replace getElementsByTagName here in the items variable declaration with query selector all, and just below, replace the getElementsByClassName method assigned to the highlights variable with query selector all, making sure that we update the string passed to this method to .highlight since we're targeting a class. And to get more practice with document.querySelector, I'll change the ID of this first button element to a class. Then in my JavaScript, change the selection method from getElementById to querySelector .button-main. I'll save my file, then refresh the browser to make sure that everything works as expected. And it does. As you can see, these DOM selection methods are really powerful and flexible.
You've learned various ways to select elements so far, and in some cases, different ways to make the same selections. You may be wondering, how do I know I'm using the right tool to select the right elements? Good question. Part of the answer is going to be shaped by your HTML. Are there IDs on the elements you want to select? Do you want to select all elements with a given tag or class name? Or perhaps you want your selection methods to be more flexible, accepting IDs, classes, tag names, and other CSS selectors. Keep in mind that some methods return the first matching element, while others return a collection or list of all matching elements. It's a lot of information to keep track of, so I've provided resources to help you evaluate the tools you wish to use for your projects in the teacher's notes with this video.
Hey everyone, it's time to start shaking things up a little more in our daily task web app, starting with how to read and change content. In this video, I'll teach you two DOM element properties, text content and inner HTML. Each provides a different way to read or update content in the DOM. You're going to learn when it might be best to use one property over the other. First, let's look at the text content property, which enables you to read or set the text content of an element in the DOM. By text content, I'm referring to only the text inside the element and not the HTML tags. Let's quickly examine how this property works in the browser console by selecting the h1 element and reading its text. I'll open up the console and first select the h1 using document.querySelector h1. Then return its text content with .text content. Press enter and we get the heading's text back. If we assign a string to text content, we can also change the heading text. For example, I'll use the equal sign or the assignment operator to assign text content the string, "This is a new heading." I'll press enter and the heading text updates on the page. Now let's move back into our workspace and use text content to make our page a little more interesting. We'll add a text input field to change the heading text. In index.html, you'll notice a label and input element commented out inside the header. Let's uncomment them to display the text input field on the page. For this project demo, the label is visually hidden from the page using CSS, but still readable by screen readers. In many cases, it's helpful to have the label present, especially as you want your content to also be accessible to those with cognitive disabilities. More about this in the teacher's notes. Next, in app.js, we're not going to need the example for of and for loops, as well as the items and highlights variables moving forward, so I'm going to delete these. Now don't worry, you can access and review all the code written in this course by downloading the project files. Let's start by selecting the new input element and assigning it to a variable. We've already set up an event listener on this update button to listen for clicks. Currently, the function updates the heading's border and font size styles. Let's update this event listener function to set the heading's text content to the value entered into the text field on click. Inside the function, I'll declare a locally scoped variable named input and assign it the input element using document.querySelector. The input element has a class of input-main, so I'll pass the method the string .input-main. I'm declaring this variable and assigning it an element within the function scope so that we can reference it inside this function only. Remember, a variable in the global scope can be accessed and in some cases updated from anywhere in the program, which, as you've learned in previous courses, could create problems. Declaring the variable in the function also provides better code readability and maintenance. So for those reasons, let's also move the headline variable declaration inside this function. When the button is clicked, we'll get the text inputs value and use it to set the heading text. To get the value of a text input field, you use the value property. For instance, input.value is going to read the value typed into this new field. For example, if I log this to the console, then in the browser, type hello console into the text field and click the button, we see hello console logged to the console. Back in my function, I'll update the heading text by setting the heading's text content property to input.value with headline.textContent equals input.value. Let's save the file, go to the browser and refresh. Now type in this field, for example, hello headline, and click the button. And that updates the heading text. Good. Now we're interacting with the heading element in the DOM. Notice the text I typed into this input isn't getting cleared after clicking the button. Inside the event listeners function, I'll clear the input field as soon as the headline text gets updated by setting the value attribute of the input element to an empty string. And this clears the text field upon clicking the button and updating the heading. The inner HTML property offers another way of altering content. The main difference between inner HTML and text content is that inner HTML can do a whole lot more than get or set text content. Inner HTML gets or sets the actual HTML markup contained within an element. We used inner HTML at the beginning of the course, for instance, to replace the inner HTML of the body with a heading that read, "Hello World." It may also look familiar because you've used it in previous courses to add or replace HTML inside an element dynamically with JavaScript. For example, in the browser, I'll select the UL elements in the console with document.querySelector, UL. I can access all the HTML markup within the UL element with .inner HTML. This returns a string of all the LI elements inside the UL. And what's more, setting the UL's inner HTML property to a string of HTML tags, like LI tags with the text read a book, replaces the UL's child contents with that markup. So now there's only one list item within the UL because I replaced all the contents with this new HTML. All right, you've learned how to alter the text content and inner HTML of an element in the DOM. I really encourage you to experiment with getting and setting the content of various elements on a page. For instance, visit your favorite website and have a little fun making changes to the content with JavaScript in your browser console. Next, we'll take a look at how to change an element's attribute. When the browser loads a web page, all the HTML tags are converted into objects called nodes and placed into a tree-like structure, the DOM. That's what lets you modify them with JavaScript. Like the href attribute of an anchor element or the action attribute of a form element, attributes exist as properties of those element objects. You get or set those attributes by way of properties, similar to the way we did earlier with an input element's value property and a heading's text content property. Let's head over to the browser console and access some of the attributes of elements in index.html. I'll first select the input element in the console with document.query selector input. For this example, I'll assign the input to the variable myInput. The input element has a type attribute, which I can access with .type. For example, myInput.type outputs the string text. Let's assign the type property the string checkbox and see what happens. Notice how the browser replaces the text field with a checkbox. Viewing the live document in the Elements panel shows that the input's type attribute changed to checkbox, and refreshing the page resets the type value to text. Similarly, you're also able to add new attributes inside an element's opening HTML tag. For example, I'll set the title attribute and value on the input element with myInput.title equals type heading text here. Now, when you place your mouse over the text field, a tooltip appears displaying type heading text here, indicating that the title attribute was set. And in the Elements panel, you can see the input element's new title attribute and value. The title attribute is often used to help identify form controls to users. So normally a title attribute would be better set directly in the HTML and not with JavaScript. I just wanted to show you how setting new attributes worked. How about I try to read the input's class name? I'll type myInput.class, and this returns undefined. Well, class is an exception among attributes. It turns out that in JavaScript, class is a reserved word used to create a special type of function called a class. You'll learn more about those in a later course. Right now, all you need to remember is that you're not able to get and set the value of an element's class attribute using .class. Instead, you need to use the class name property. For instance, myInput.className returns the string input-main. I can also set a different class name by assigning the class name property a string like checkbox-update. Typing myInput.className returns the updated string. And notice in the Elements panel how the input element's class attribute is now checkbox-update. And refreshing the page resets it to the initial class. Using .class is a common and easy mistake to make when getting or setting class attribute values. So remember that it's class name and not class. I'll give you a chance to practice that now to help make it stick. In the file style.css, there's a class selector named grow, declaring a font size value of 4.8 rem and a transition. Here in the button update event listener, why don't you set the headline elements class to the value grow? That way, clicking the button not only updates the heading text, but also applies a transition, increasing its font size. Feel free to pause me now and try it out. Okay, within the event listener's function, type headline.className and set it to the string grow. Let's try it. Refresh the browser, then type Hello Headline into the text field and click the button. The text changes and transitions to a larger font size. Neat. And in the Elements panel, notice how the H1 now has a class attribute and its value is grow. Setting class names with JavaScript can be useful when you want to show or hide elements or add error indicators to form fields when users enter invalid information, for example. You can add a class attribute to an element with a class that hides content or a class that displays a form validation error. Up next, I'll teach you more about a property that you've already worked with, an element's style property. You've learned that you can set inline styles on an HTML element with the style attribute. The styles set in this way override those set within an external style sheet. In most cases, you'd style elements directly in an external style sheet, but there will be times when you'll use JavaScript to modify element styles in response to some user interaction, for instance. Like most other attributes, you can get and set the inline style of an element in the DOM with the style property. However, unlike most other attributes, the style property returns an object containing a list of all the CSS style properties you can set. Let's look at this in the console. I'll type our button update variable that's declared in app.js, which holds a reference to the page's update heading button. To access its style property, I'll type .style. This returns a CSS style declaration object. Expanding it displays all the style-related properties, like background, background color, border, and a whole lot more. Notice how all property names with 2 or more words, like background color, background image, and border color, are in camel case. This is different from how you'd write them in CSS with dashes between each word. JavaScript's core methods and properties all use camel case, including all DOM properties, attributes, and event handlers. The inline CSS style declaration properties are no different, and it's important to remember when working with the style property. These properties only get or set the element's inline styles and do not refer to any CSS applied from a separate CSS file. Because of that, the CSS style declaration objects properties are generally used to set styles versus get style values. At the beginning of this course, you used some of them to set the body's background color with style.backgroundColor and the button's text color with style.color, for example. Let's try a few more style properties here in the console. First, button update.style border bottom equals 5 pixels solid deep pink applies a bright pink bottom border to the button. And button update.style background color medium violet red changes the background color of the button to red violet. One common use for setting a style with JavaScript is to hide and unhide elements on the page. In our project, let's set up a button that will toggle our task list in and out of view like this. In index.html, there's a button element with the class button toggle. The button displays above the task list, initially showing the text hide list. Back in app.js, let's first select the button. I'll declare a variable named button toggle at the top of the file and assign it the button element with the class button toggle using the handy document.querySelector method. Next, to make something happen on the page when the button gets clicked, I'll need to add an event listener to the button that listens for the click event. I'll set that up here in my JavaScript file with button toggle.addEventListener. I'll pass the method the string click, followed by an arrow function. When a user clicks the toggle button, we'll want to hide this div with the class listContainer. We can do that by setting the div CSS display property to none. First, let's select that div here within the function. I'll assign it to a variable named listContainer. Then to hide the div, type listContainer .style .display equals the string none. I'll save my file, switch back to the browser, and refresh. Clicking the button makes the list container disappear. Great. Clicking again, though, does not make it reappear. I'll need to do a little more work with the event listener to make our toggle button completely functional. When the function passed into the event listener runs, it should show the list if it's hidden and hide the list if it's visible. Notice I used the word if. This is the perfect case to use a conditional. I'll start by adding if and else statements inside this function. First, as the if statement, I'll write listContainer .style .display equals the string block. Then for else, add listContainer .style .display none. The function will either show or hide the list. So what should we write as the condition that decides which code block to run? Well, we can check the list container's inline display value, which we're setting here with JavaScript. In the condition, I'll check if listContainer .style .display strictly equals none. So if display is set to none, the function will set the list container's display value to block, making the list appear on the page. Else, it will hide the list by setting its display value to none. Let's save our file and have a look in the browser. When the page first loads, the list container does not have an inline display property, as you can see here in the Elements panel. So when we first click the button, our condition evaluates to false, and the else statement sets the display to none. Clicking the button again sets the display to block, making it reappear. Good. Now, when we click to hide the list, the button text is hide list. The list is already hidden, so that's confusing. Next, let's change the button's text, depending on whether it's hiding or showing the list. We can use the text content property to set the text. In the if block, I'll add button toggle .text content equals the string hide list. Then for else, write button toggle .text content equals show list. Let's try it. Good. Now the button's text changes as expected, letting the user know what's going to happen on click. Finally, div elements like the list container by default display as block level elements, so setting an inline display of block here seems a bit unnecessary. So let's instead remove the inline style attribute from the list container. You can remove an attribute from an element, like style, using the remove attribute method. In the if statement, change this line to list container .remove attribute, followed by a set of parentheses. The method accepts a string specifying the name of the attribute to remove from the element, in this case, the style attribute. I'll save my file, Back in the browser, everything still works as expected, but notice in the Elements panel how the style attribute gets removed from the div when you click to display the list. All right, next up, you'll learn how to create elements and add them to the DOM. So far, we've only read values and changed the elements on our page with JavaScript. Now you're going to begin learning how to create new elements and add them to the page. For instance, in a to-do list application, a user needs a way to add a to-do item to the list. This action requires that we provide a way to add a node to the DOM, like the node representing a list item. There are various ways you might add elements to the DOM with JavaScript. For example, you learned that setting an element's inner HTML property to a string containing HTML tags sets the markup to display within the element. But that property replaces all the existing contents of the element with just the new content. What if you need to preserve the original markup? It's common to append or add newly created elements alongside existing sibling elements. For example, a simple to-do list might be an unordered list containing list items displaying each to-do. As you enter new to-dos, new list items get created and added to the beginning or end of the list. First, I'll teach you how to create a new element with document.createElement. Then later, you'll learn how to insert a newly created element into the DOM. Back in our project, let's add a feature that allows users to add new items to the daily task list. We'll update our code to let users type a new task into this text input, then click the button to create the new task and make it appear in the list. In the index.html file, let's start by changing the header button's text to add task. I'll save my file. And over in app.js, I'm also going to update the button update variable name to button create, a more meaningful name indicating that the purpose of the button assigned to this variable is to create an element. Next, I'll need to update my event listener with the new variable name. And now I'm going to delete the headline variable from this function and the 2 lines of code that reference it, because we're no longer going to be updating the headline. That was just a simple demo to help introduce the concept of DOM manipulation. Now we're going to take things up a notch. Again, you can access and review all the code written in this course by downloading the project files. Within this function, we'll create a new list item element with the createElement method. First, I'll declare a variable named item, then assign it the newly created element with document.createElement, followed by a set of parentheses. To create a new element, pass document.createElement the tag name of the HTML element you want to create as a string. In this case, li. I'll quickly demonstrate how this method works by copying this declaration and pasting it here in the browser console. Then on the next line, type item, and we see that it returns a set of li tags. Once the element gets created, we can set the text inside it with the text content property. The list item's text content should be the value entered into the text input. So back in our function, let's assign item.textContent the value of the text field with input.value. I'll save my file. Back in the browser, I'll refresh and enter some text and click Add Task, and nothing happens. Well, that's because even though we've created the element, we haven't added it to the DOM yet. Right now, we're creating free-floating elements that exist only in memory somewhere. For example, here in the event listener, I'll log the value of the item variable to the console. I'll once again enter some text into the field and click the button. This time, the console outputs the newly created list item with the text read a book. Up next, you'll learn how to insert this content into the DOM.
Earlier, you learned how to create elements with JavaScript, but the newly created elements won't appear on the page until you add them to the DOM. Remember earlier when we talked about the DOM being a tree-like structure with nodes? That tree is what we'll use to place our new element or DOM node. We'll do that by specifying an existing parent node, like a UL, and then using the .append method to append or add a new child node inside it, like an LI. If you're still not quite sure about the difference between an element and a node, you can think of them as being mostly interchangeable, which is how I've referred to them in this course. Nodes are all the different components that make up the DOM. A node can be any object in the DOM tree, not just an HTML element. For example, the text within HTML tags is considered as a node. An element is a specific type of node that is directly specified in the document with an HTML tag and has properties like an ID or a class, and can have child elements.
Let's determine where we want to append the list item we created earlier. In index.html, all the list items are nested inside this UL element. So the UL is the parent element, and the LIs are the children. So if we select the UL and append a child LI to it, the LI will appear as the last item after play my guitar in this case. Let's switch over to app.js and append the list item. The first step is to select or reference the parent element, which in our case is the UL. Inside this event listener function, let's declare a variable named list and assign it the UL element with document.querySelector. After we've created the new list item, we can append it to the list using the append method. Below, type list.append, followed by a set of parentheses. You pass append the node or set of nodes to append to the given parent node. I'll pass it the newly created list item assigned to the item variable. Let's save this, switch to the browser, and refresh. I'll type write a blog post and click the button. And good, it works. I've created a new list item element and added it to the DOM. Add another item, say go for a walk, and see it added to the end of the list. The append method will always add the new node to the end or after the last child of the specified element. To add each new list item to the beginning of the list as the first child, you can use the prepend method. I'll type a task into the text field, click the button, and now the new task appears at the top of the list. Be sure to check the teacher's notes with this video to learn more about browser support for the append and prepend methods and alternative DOM insertion methods. Finally, it's important to alert screen readers anytime elements are dynamically updated and added to the DOM, like items in an unordered list. Notice the ARIA Live attribute added to the UL. The ARIA Live attribute lets screen readers know that content in a particular element will change dynamically and that it should pay attention to it and announce those changes to the user. Setting the value to polite means that the announcement will occur when the screen reader has finished the current task or announcement versus interrupting it. In addition, it's important to test the accessibility of content added to the DOM, especially on larger projects where updates are frequently being made to the page. In the teacher's notes, I've posted more information about tools you can use to test your projects to help identify and resolve common accessibility issues involving dynamic content. Next, I'll teach you one more convenient method for inserting HTML and its contents into the DOM. There are various ways to create elements and insert them into the DOM. Earlier, you used createElement to create a new list item. You set its content using the text content property, then added it to the daily task list using the append and prepend methods. Now you're going to learn how to use the insertAdjacentHTML method to insert elements into the DOM. This method provides more control over inserting HTML inside a parent. You pass it the HTML and text content to create as a string, and then that string gets parsed and inserted into the DOM at the position you specify. Let's see what this looks like when creating our task list items. First, in my button create add event listener function, I'll delete the lines of code where I used createElement, item.textContent, and the append and prepend methods. Remember, you can always review this code in the project files with this course. We want to create and add list item elements to the task list, which is the UL assigned to the list variable. So let's call the insertAdjacentHTML method on the list variable. I'll create a little extra space between the parentheses because we're going to be passing the method some information about what we want to insert. This method accepts two arguments: a position argument instructing where inside this element you want to insert the HTML, and the actual HTML string you want to insert into the element. You can use one of four options for the position argument. Each lets you insert the HTML in a different location relative to the parent element. For example, before or after the parent, or just before or after its first or last child. You can review each position argument in the teacher's notes. I'm going to pass it the string after begin, which inserts the content inside the element just before its first child. In our case, it will appear at the top of the task list. And what do we want to insert? A new list item. So as the second argument, I'll use a template literal to build the new list item. Inside the backticks, add opening and closing li tags. Then I'll use string interpolation with $ curly braces to dynamically insert the value of the text input field inside the list item with input.value. To recap, insertAdjacentHTML will parse this template string as HTML, then insert the list item into the DOM tree as the first child of the list. Let's save this file, refresh the browser, and type a task into the text field. Click Add Task, and it works just as expected. Good. InsertAdjacentHTML in many cases is faster and more efficient than other insertion methods. You can build a new element, set its text content, and then insert it into the DOM all with one method. Next, I'll teach you how to remove an element from the DOM.
You've come a long way with selecting and manipulating elements. The last thing we're going to look at in this course is removing elements from the page. For example, in a browser-based to-do list application, a user might want to remove a to-do item from the list when they complete it, or maybe delete a photo from an online photo gallery. These actions require that we provide a way to remove a node from the DOM, like the node representing that list item or image element, for instance. One way to achieve this is with the remove method. You specify the child node to remove from the DOM and call the remove method on it.
Let's use the remove method to remove the last list item or task in our list upon clicking the Remove Last Task button at the bottom of the list. Over in app.js, we'll follow some of the same steps we took earlier when adding items to the list. We'll access the button to click, add an event listener on the button that listens for the click event, and this time we'll call the remove method on the last child list item. At the top of app.js, I'll declare a variable named button remove and assign it the remove button. I'll use the document.querySelector method to access the button, which has the class button-remove. Next, I'll create my new event listener by calling the add event listener method on button remove. I'll pass the method click, since we're listening for the click, and the function to run when the click happens. Within the function, I'll select the list item that is the last child of the unordered list and assign it to the variable last item. The query selector method comes in really handy in this case. I can use the last child CSS pseudo class as my selector string with li colon last dash child. The last child selector targets the last element among a group of sibling elements. You can learn more about it in the teacher's notes. Once we have access to the last child li, we call the remove method on it to remove it from the DOM with last item dot remove followed by a set of parentheses. And that should do it. Let's save our file and have a look in the browser. I'll refresh the page and see that my last task is play my guitar. Clicking the remove last task button removes it from the list. Clicking the button again removes another task. And good, it's working. And notice how those list items no longer appear as children of the UL here in the Elements panel. In an upcoming JavaScript course about the DOM, you'll learn how to access and remove specific elements from the DOM, like a specific task in the list. Check the teacher's notes for the link to the course.
You've learned many essential concepts and tools to help you make your web pages interactive with JavaScript. You can select elements on the page, change those elements, create elements, add them to the DOM, and remove them. There is so much more to learn about making web pages interactive with JavaScript in the DOM. In a follow-up course, you'll dive deeper into event listeners and browser events and learn convenient ways to access nodes and navigating the DOM based on the relationships between elements in the DOM. Before then, I strongly encourage you to continue experimenting with the different methods, properties, and techniques to get more practice accessing and interacting with the DOM. Thanks everyone, and happy coding.